Students, welcome back to the series of lectures for basic civil engineering of your first year. I'm Professor Mayuri Patel, and today I'm going to discuss with you about engineering mechanics, which is a very important part in civil engineering and a very important topic for your all of you for this particular subject. In this my presentation today, lectures, I would be giving you introduction about what exactly is engineering mechanics, what are the different system of units which are being used while solving the numericals, what is the force and its concept, and what are the different system of forces. Basically, engineering mechanics is divided into two parts. The one part of it is statistics, the other one is dynamics. In the dynamics, we again study about kinetics and the kinematics. We'll be studying one by one today. So, what exactly is statics? It is a branch which deals with the forces and the effects, often on an object or a body at rest. Means what? Basically, a branch of engineering which deals about the forces and their effects on a particular object or on any body which is at rest. For example, uh, if we have an object or a body at rest, we deal with the forces and the effects that are acting on the body, then we are dealing with the static branch of engineering mechanics. What exactly is dynamics? It is branch which deals with the forces and their effects on the bodies which are in motion. Means what? The moving bodies basically. Suppose I'm studying about a ball coming towards you or a vehicle moving. It means I'm studying dynamics of portion or dynamics topic of my engineering mechanics. I would try to repeat. If we are dealing about the forces and the effects on an object or a body at rest, it is statics. And if we study about the forces and their effects on the body in motion, that is called as dynamics. Now, as I've said earlier, dynamics again has two variation into it. The very first one is kinetics. Kinetics is defined as a branch of dynamics which deals with the bodies that are in motion due to the application of forces, where we actually apply forces and then we study its reaction and all. That part of dynamics is called as the kinetics, whereas the one which is one now directly with moment which is force not directly given to that particular object, but the forces come into reference with the previous one, that is the kinematics. Our next topic here, as you can see on your screen, is the what are the basic fundamental units which we are going to use to denote the particular forces or loads. The very first one is M, which capital M, which I'll highlight here. Firstly, the quantity on which we are going to focus is the mass, which I will be using the symbol capital M. The unit SI unit used for mass would be the kilogram. Generally, the symbol used for kilogram is kg. Similarly, for length, it would be meters, time it would be seconds, and the force it would be Newton. The formula for force would be force equals to mass into acceleration. As I have mentioned here in the table, the unit for force is Newton, the unit for mass is kg, and unit for acceleration, that is speed, would be meter per second square. Hence, the unit of force would be Newton, which is equal to kg per meters, kg into meter per second square. Similarly, for weight, W equals to m into g, where that is similar again, Newton equals to kg dot m per second square. Uh, this is again the similar table which I have explained earlier. Here, this table gives you can note it down, fundamental units of SI system for length, mass, time, and temperature respectively. For length, the unit would be in meters. I would be using the small m as my symbol. Mass, it would be kilogram. I'll be using kg. For time, it would be second. In SF, small s generally it is being used. For temperature, it would be Kelvin, K. This table again gives you the different units of different physical quantities which we are going to use for solving all the numericals in this particular subject. Again, the multiplication factor I've explained here. If it is 10 to 12, the prefix would be tera, the symbol would be T. If it is 10 to 9, it would be giga, the symbol would be G, and so on. Now, here many of the students generally make mistakes. So before moving on to the numericals or the actual mechanics, I would all of you please it is note down the important unit conversions which I have mentioned here. For the very, I'll be discussing very few of them. The very first one, 1 meter equals to 100 centimeter equals to 1000 mm. This we have studied in our school days also. Here, 1 megapascal equals to 1 Newton per mm square. Many times in numericals it has been mentioned as Newton per mm square, but you ask into megapascal. So don't get confused. Here, all these which I have mentioned here, all these are the very important conversions which you need to remember while solving the numericals. Yes, as you can see, degree also can be converted into radians. 1 degree equals to pi by 180 radians. All of us know the value of pi. It is 3.14. 1 kgf equals to 9.81 Newton. And 1 kilonewton equals to 10 raised to 3 Newton, and so on. Now, as you can see in the diagram, what exactly is force? Force means what we are performing, you can say. Numerical wise, or formula wise, we have seen in the previous slide that force equals to mass into acceleration. Acceleration means speed, and mass is generally related to your weight. So, by how much weight we are giving speed to a certain object, that relates to a force. As you can see, these are different types of forces which are being given. This the very first activity for applying force is push, then pulling, magnetism, gravity, friction, and you can say sliding. So these are the various you can say variations of applying forces. Push and pull. So we push the door to shut it or open it. A baby walks by pushing a baby walker. These are few of the example of pushing. And for pulling, when we pull a bucket full of water by applying a pull. A load lifted using by pulleys or example of pull. Now, what is the necessity of force? The very first one is to move a stationary object, means what, an object which is at rest. To move it from one place to the other, we need a force. To change the direction of motion, suppose I'm moving straight, but if I'm given a force to move in the different direction, it can be given. So whenever I need to change the direction of motion, a force is required. To change the magnitude of the velocity of motion of an object. Suppose an object is moving. If I need to change its speed, I need to give it certain force. Yes, of course. So there also we need force. And to change the shape of an object. If a shape has a object has a particular shape, by giving it force into different frequency and radiations, we can change the shape of the object also. So these are the necessity of forces. What are the effects of force? Uh, Obviously, the in the previous slide I've shown you what are the necessity. Obviously, to fulfill the necessity is the effect of force. I've mentioned some of them. It may set a body into a motion, means it would ask the body to move or to act. It may bring a body to rest. Yes, it stops the body. It may change the magnitude of motion. At what magnitude of body is moving, it can be changed with the help of force. It may change the direction of motion. It may change the magnitude as well as direction at the same time. Nextly, it may change the shape of an object. Yeah. These are the characteristics of force. Basically, there are four characteristics of forces: direction, magnitude, the point on which it acts, and the line of action. Line of action means the way it is being applied. Here, you can see in the three particular diagram, the very first one shows me the activity for tension. This is the load. This load is fixed with a string from a fixed end. Okay, so here the type of force created is the tension. Here I'm giving you the symbol for weight. A body is moving on an inclined surface, so its load would be directly or indirectly coming on the ground. So how it would be passing towards the center, this is the weight force, and these are the reactions. This in this particular uh, way, we are going to mention the different forces applying on a body. So as I've said, direction, magnitude, point on which the force acts, and the line of action. These are four characteristics of force. The next topic for discussion is line of action of force. Line of action of force, say F, is a geometric representation of how the force is applied. As you can see here in a diagram, E1, E2, E3, these are nothing but the line of action. In this particular, the you can see the pointer. This is the pointer in which the direction, suppose force E1 is moving. So this would be the line of action for the force E1. This is the line of action for force E3, and this is the line of action for force E2. So it is nothing but the line through the point at which the force is applied in the same direction as the vector F. So here in this particular diagram, I am trying to uh, show you what are the different in what ways forces can be enacted. So say if it comes into gravity, if it comes in relation with mass and weight, with balanced force and with the unbalanced forces, we'll be discussing it in the further topics. So now we'll be talking about what are different systems of forces. Basically, when two or more forces acts on a body, then they are called as a system of forces. When on a same object or a same body at the same time, two or more than two different forces act, then we call the entire structure as the system of forces. There are four basically system of forces which we are going to discuss today: coplanar force system, concurrent and non-concurrent force system, collinear and non-collinear force system, parallel, that is like and unlike force system. Here is the tabular representation of different types of system of forces: coplanar and non-coplanar. In the coplanar, we have again three variations, that is collinear, concurrent, non-concurrent, and in non-coplanar again concurrent and non-concurrent. We'll be discussing here onwards. So these are the coplanar forces. Coplanar forces are also nothing but those which are acted on the same plane. Just as you can see here in the first diagram, these are coplanar. Means what? This is a particular area or a plane, and in that particular area, uh, in uh, in spite, or you can say the without giving the dependency upon the direction of a force, but they represent in the same plane. Means what? The forces are acting in that particular area. Means what? For example, all of you are studying in, suppose, AML branch. Okay, so all of you may have different interest of studies, but what is common amongst you? The common thing amongst you is that you are into AML. Similarly, here F1, F2, F3, as you can see here in the diagram, all these are different forces, but the common thing is that they are in the same plane. Hence, we mention them as the coplanar forces. Nextly is coplanar concurrent forces. Here, as you can see, they are in a single plane, but they intersect at one particular point, but they are moving in three different directions. Hence, we can say they are coplanar and concurrent forces. Next is your coplanar parallel forces. Parallel means what? They never intersect with each other. So see, as you can see in this particular diagram, they are passing through one same plane, but they are into parallel directions. Hence, they are called as coplanar parallel forces. And the last diagram here shows you coplanar non-concurrent non-parallel forces. They are in a single plane, but they are not concurrent. Means what? They do not intersect at one point, neither do they neither they are parallel to each other. Hence they are named as coplanar non-concurrent non-parallel forces. I'll repeat: coplanar are those which are on one plane. Coplanar concurrent are which in one plane and having one common intersection point. Coplanar parallel forces are in the one plane in but not intersecting and moving parallelly. And coplanar non-concurrent non-parallel are in a same plane but neither intersecting, neither they are parallel with each other. Now, this gives me the representation of non-coplanar force system in the 3D view. So here, as you can see here, non-coplanar concurrent system of forces. All of them are moving towards one common point. Hence, they are called as concurrent one. These are non-coplanar, non-concurrent. Neither they are in a single plane nor they are intersecting. Hence, they are non-coplanar, non-concurrent system of forces. And the last one is non-coplanar parallel system. Even though they are not on the same plane, but they are parallel to moving parallelly. Hence, they are called as non-coplanar parallel system of forces. Nextly, we have concurrent and non-concurrent forces and non-concurrent. As I've already explained you in the previous diagram. Here are the collinear and non-collinear system. Again, the forces which are moving in the same direction in a single line are called as the collinear forces. The forces which are moving differently, they are not in the same line, which are not linear, they are called as the non-collinear forces. Nextly, we have parallel force system. The forces which move parallel to each other, either in the same direction or in the different direction, they are called as parallel forces. If they are into same direction, they are called as like parallel forces. If they are into opposite one, they are called as the unlike parallel forces. Thank you, dear students. Keep studying. We'll be discussing more mechanics in a few further classes.